Hello everyone, this is Angela Plaku and welcome to Earth Climate System Assessment 3. The project I'll be presenting is on the environmental impact of lithium mining in Chile.
Lithium is a chemical element that can be found in brine deposits at salty mineral spring. It is also the largest known metal with the highest electrochemical potential. Much of the Earth's lithium, nearly 8 million megatons, are stored in the form of lithium carbonate in the renowned lithium triangle between Argentina, Bolivia and Chile. As you can see, we'll be focusing on the Atacama production plant, which is powered by the two companies SQM and Albemarle. Lithium is needed to produce virtually all traction batteries currently used in electric vehicles as well as consumer electronics. Moreover, lithium-ion batteries are widely used in many other applications like energy storage or air mobility. Indeed, lithium-ion applications are towards batteries, which accounts for 46% of the total, 27% towards glass and ceramics production, 7% on lubricating greases, 5% on polymer production, and 9% on other purposes like pharmaceutical, electronics, aluminium, and so on. The insatiable demand for the latest smartphone or computer brings along a need to transition to clean energy, where lithium, with its high electrical conductivity, is key to many rechargeable devices, for which, as you can see from the graph, global sales are expected to rise for 2030 and actually expected to quintuple over the next 35 years. Lithium mining is based on evaporation techniques. First, miners drill into salt flats and then pump salty lithium brine water to the surface. Then the pools, or actually solar evaporation tanks, which is the actual term, are left up to 18 months so that the liquid can evaporate. And then the lithium carbonate left behind can be refined into metallic lithium, which is the convenient form used for electronics. Well, until the 1990s, the lithium leading producers were the United States, but then shifting to the beginning of the 21st century, actually most production was obtained from Australia, Chile, and Portugal. However, Bolivia has half the world's lithium deposits, but it's not a major producer of lithium. Indeed, we can see that 24% of global lithium resources are held in Bolivia, followed by 22% from Argentina and 11%, so almost a quarter of the global lithium resources obtained in Chile. And now, focusing on the Chile's lithium market, we can see that Atacama is one of the biggest mining districts of the planet. And indeed, Chile has already exported nearly $1 billion of lithium, planning also to expand their production, but at the same time 1.5 trillion liters of more water are predicted to evaporate by 2043. Usually, extraction and processing are water and energy intensive, and they usually contaminate water and soil. But along these changes to the natural environment, mining is also linked to human rights abuses, respiratory ailments and diseases, dispossession of indigenous territory, and labor exploitation. Besides, lithium extraction processes are chemically intensive and slow, and they also produce large volumes of waste. Therefore, mining practices lead to water shortages, which can not only compromise the lagging structure but also jeopardize the entire ecological value of these hypersaline lakes. As one of the driest places on the planet, The mine's reliance and dependence on water for extraction exacerbates the region's water scarcity and reinforces the shrinking down of meadows and lagoons. Indeed, for every ton of lithium extracted, it requires some 500,000 gallons of water. And plus, the mining activities already consumed 65% of Atacama water supply. Lithium mining is also affecting biodiversity by, for example, exploiting important staging areas for inter-hemispheric bird migrations. But at the same time, the changing of the salinity and the water availability alters the food chain, and therefore Andean flamingo species populations are declining. As we previously mentioned, in Chile Salar de Atacama, mining activities already consumed 65% of the region's water. That is having a huge impact on local farmers and 18 indigenous Atacameño communities who grow quinoa and llamas in an area where, unfortunately, some communities already have to get water from somewhere else. Hence, advocates and local communities are calling for the brine to be regulated not as a mineral, but as water, in order to grant not just greater resource protections, but also human rights protection, especially towards the indigenous communities. Therefore, the local community proposal is a reaction to the Chile's government action. Indeed, the government has planned to incentivize the mining industry by granting new extraction quotas to mining companies for 2030, which of course raises a concern on how we can basically find a balance between economic development and nature conservation. So learning about this fact could raise an uncomfortable question, which is, does fighting the climate crisis mean sacrificing communities and ecosystems? Since the supply chains that produce green technologies begin in extractive frontiers such as the Atacama Desert. A possible solution to the question would be applying and adopting a circular approach to the lithium mining. Indeed, lithium ions are only a minor component of the brine. Therefore, from a circular economic perspective, there is potential for extraction of more than one valuable mineral, like potassium or magnesium. So, applying the circular economy thinking would not only reduce the liability but also increase the value of waste materials arising from the mining and processing operations. Thank you for your attention. Bye!